Question 5, Part B, Part 1. Show that d dx of log base e of cos x equals negative tan x. Y equals ln of cos x is an example of a composite function, or a function of a function. Hence, apply the chain rule to find the first derivative dy dx. So using the chain rule, dy dx is equal to the derivative of the outer function, which is the ln function, and that's 1 over cos x, multiplied by the derivative of the inner function. So the derivative of cos x is negative sin x. So putting that all together, we get dy dx is equal to negative sin x over cos x, which equals negative tan x as required. Part 2. The shaded region in the diagram is bounded by the curve y equals tan x and the lines y equals x and x equals pi over 4. Using the result of Part 1, or otherwise, find the area of the shaded region. The area of the shaded region is the difference between the area under the curve y equals tan x and the area under the line y equals x from x equals 0 to x equals pi over 4. And that's given by the integral of tan x dx from x equals 0 to x equals pi over 4 minus the area of the isosceles triangle bounded by the lines y equals x, the x-axis, and the vertical line x equals pi over 4. So we have a triangle with a base of pi over 4 and a vertical height of pi over 4, so we can use the half times base times height formula to find the area of the isosceles triangle. Now we can use the result in Part 1 to find the integral of tan x dx by changing the positive tan x into a negative tan x. If you recall, the derivative of ln of cos x is negative tan x, so integrating negative tan x we get ln of cos x. So we can change the positive tan x into a negative tan x, and then cancelling the negative in front of the tan x by placing another negative in front of the integral itself. The expression becomes negative integral of negative tan x dx from x equals 0 to x equals pi over 4 minus half times base times height, so half times pi over 4 times pi over 4. Using the result from Part 1 to help us integrate negative tan x dx, we get negative ln of cos x. So this negative here comes from this negative here, from x equals 0 to x equals pi over 4 minus pi squared over 32. Applying the limits of integration, we get negative ln of cos of pi over 4 minus negative ln of cos of 0 minus pi squared over 32. Now cos of pi over 4 is an exact ratio, that's root 2 over 2. And cos of 0 is 1. So we get negative ln of root 2 over 2 plus ln of 1 minus pi squared over 32. Now ln of 1 is 0. And we can turn this negative ln into a positive ln by taking the reciprocal of root 2 over 2, so it becomes 2 over root 2. So the expression is ln of 2 over root 2 minus pi squared over 32. We can simplify the logarithm even further, and ln of 2 over root 2 is ln of root 2. And root 2 is 2 to the power of half. So this can simplify even further still, and it becomes half times ln of 2. So the area of the shaded region is half ln of 2 minus pi squared over 32 square units in exact form, or 0.0381 square units, correct to 4 decimal places.